Thank you for the kind intro. Delighted to be here and chat about multimodal AI in medicine. Over the past year, I've been thinking a lot about what happens when we have AI systems that are going to be extremely good and out in the world, and we have to decide, well, what do we do with people?
Can we pause for a second before? Sorry. Share your screen on the Zoom again.
Yeah.
Okay. Mute yourself. Muted. Okay, perfect. Now we're good.
Perfect.
Maximize it.
Okay, so I want to start by sharing with you a couple of studies that test this approach of what happens when you put people and AI together. This was a study that I worked on with some colleagues at MIT, where we were testing the question, does providing an AI tool to physicians enhance their diagnostic support? Does the combination of the AI and the doctor actually outperform the doctor or the AI alone? And this was a large-scale experiment done with over 220 radiologists, in which the setup was you get to look at an X-ray image, you get to look at the associated clinical history, lab values if those are available, and then you're tasked with making a binary yes-no decision as well as a likelihood prediction on several conditions. And so I want to share what happens as a result. The surprising reality was that this model could outperform 78% of radiologists, but on average did not improve the performance of the radiologists when used in an assisted format. Now that seems interesting. Why is that? It turned out that when AI was confident, the collaboration was successful, the treatment effect was positive. But when the AI showed uncertainty in its prediction, it was actually driving the decisions in the wrong direction. We tried to explore if there is some way to predict when this collaboration is going to succeed, when it's going to fail. This is a Nature Medicine paper that we published this year, that was talking about the heterogeneity in the performance of radiologists. Same experimental setup, 140 radiologists now, and we're going to ask the question, are factors like your specialty, your experience with AI tools predictive of the success? And the key finding was that the experience level did not actually predict the AI success. In fact, what we found is when we looked at years of experience or their specialty or their experience with AI tools, none of those actually stratified or was able to predict who was going to benefit with AI. So what this leads us to is maybe in the world in which we have expert level AI, we need to personalize how it's deployed to actually improve the performance of the downstream user. Now, this is a set of studies that are part of a broader set of studies now that have the same showcase, that the combination of the two is outperformed by the AI alone, even if it outperforms the human alone. And some of this work has been in imaging, some of this work has been multimodal, and I'll share a few examples over the next few slides. I want to, of course, also share some successes of human AI collaboration, so I'll start there. So the Messiah trial is a large trial that happened in Sweden, 100,000 women, and the setup was, rather than a standard double read on every mammo, what's going to happen is AI is going to decide if something should receive a single read or a double read, depending on the confidence that it has on a scan being normal. And so what this showed was that with this setup, there was a 29% increase in cancer detection. There is a 44% reduction in workload. So that's great. Maybe in Europe, we'll go from double read to single read with AI triage of whether or not something should be double read. At the same time, this trial in Germany called the Pranav trial, looking at 12 German reading sites, I think this was 300,000 women, actually allowed the radiologist to choose when they wanted to use AI and when they did not want to activate AI. So sort of a natural experiment on that front. And what they found was that when given flexibility in the AI use, radiologists used AI for viewing routine cases, while for the complex ones actually decided not to even look at what the AI was saying. Pretty interesting, pretty counterintuitive. This is a paper that was led out of Vivek's group at Google. Also had the characteristic that when you put AI in combination with people, it has improvement in performance, but not as good as the AI alone. And this was some of the work that we saw earlier today. So this begs the question, are we forcing a collaboration where there might be a better way to go about the deployment in a way that's synergistic for the human and for the AI? And this was a piece that I co-wrote with my colleague Eric Topol that appeared in the New York Times that tried to get at the ways in which we could deploy that doesn't assume a direct combination of the two in this way that would maybe be non-optimal compared to just having the AI. And so here's a proposal, is rather than have the AI just jump on in on every case, can we think about a setup of role separation? The AI does something, the human does something else. And we leverage the distinct strengths of each separate complementary responsibilities. And I want to share with you 3 examples today. One in which we have the AI go first, second in which we have the clinician go first, the AI go second, and the third in which we decide for a particular case, should it be read by AI, should it be read by an expert human? All right, so let's start with application number 1. This was a work published in Nature Medicine by one of my PhD students, Shreya, and what she did was to say, can we evaluate large language models not on their ability to do vignettes really well, but on their ability to actually have conversations with patients, extract the right history, and then come up with the diagnosis. So I want to share with you a video of what this actually looks like. So here's what a typical vignette would look like in the multimodal case. It would add images. The clinical LLM is tasked with choosing the right answer. It comes up with the right answer, leukemia. So we're going to look at the same case now, but where the history gathering abilities have to be evaluated as well. So here's a patient AI agent, comes in with a presentation. There's a conversation, a back and forth between the simulated patient agent and our clinician agent. And at the end of it, there is going to be a diagnosis. Now, this is the same case, but this time the recommendation is, why don't you take some ibuprofen for your leukemia? And that's the sort of thing, the doctors in the audience got my joke. But this is the kind of thing where you see these capabilities of these models on these well-constructed vignettes just fall apart when they're tasked with having to extract the right history from the patients. And in this case, the performance fell from 82% to 63% in terms of this conversational diagnostic accuracy. So that was where we had the AI go first, do the history gathering. That's a view of the world. Let's think about a view of the world in which we have the AI go after the clinician. So right now, radiologists look at scans, they write reports. We thought about what it would take to take those reports, take the scan, and present to the patient, explaining to them what's actually happening in their scan. So here we use an LLM for text simplification, but we're also going to supercharge it with the correspondences between the text and the images. So here's what the patient explanation actually looks like.
infection, possibly
I can narrate. There we go. So in this case, what you're seeing is the nodule and any other finding that was salient be explained, highlighted on the image, but also you can see the 3D rendering on the right. There's a simplification of the findings going on, and that's what the patient gets to see in their own scan with reference to a normal reference scan. And so they can visually compare, see, okay, this is what's going on with my scan, with my health. Empowering. We showed these videos to treating physicians and asked them, would you feel comfortable if you were supervising the patients watching them? And their answer was yes. Would you be comfortable if you weren't around the patient were just watching these? Nope, 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 nope. And the main issue related to what happens with all the incidental findings. Are patients going to be curious and going to be unnecessarily stressed as a result? And that's something we've thought about solving in the upcoming versions. Okay, so I want to shift focus a little bit to the next paradigms of AI and how this might change the picture around assistance as well. So in April 2023, the first author, Dr. Michael Moore, will speak later today, and I and a group of people got together to think about what a generalist medical AI might look like. What is an AI that can look at different kinds of data, that can solve different kinds of tasks, all as part of one trained system. And today, people are thinking about what that looks like for 2D medical images, for 3D medical volumes, for medical videos, as the vision portion of what needs to be incorporated into generalist medical AI models. Michael and I got together again, wrote a Nature paper called GenMI, where we talk about the future of multimodal generative medical AI as creating a world in which we'll have the ability to look at scans, look at videos, and be able to write about them in natural language and be able to apply that across specialties and move beyond one type of task into doing multiple types of tasks with one model. So this is what GenMI is about. And I want to share just a few examples of what sort of progress we've made along these fronts. So this is work done by one of my former postdocs at this point, now starting as assistant professor at Tsinghua, Hangzhou, and he came up with MedVersa. And his insight for MedVersa was to say, I'm going to have a unified model that's going to be capable of solving these different vision language problems, where the output's not only going to be language, but it's also going to be segmentations or object detections, all as part of one unified training framework. So collected a large data set, and on several benchmarks for vision-only tasks, for vision language tasks, set a new state-of-the-art. And I won't go into the details of what those benchmarks are. What I am more interested in sharing is what happens in regard to real-world use or use by clinicians. And so one of the experiments we did was to say, we're going to have, on a set of cases, these models generate reports. These are looking at scans, generating reports, and we're going to have the same thing be done by people, and we're going to ask another group of experts to guess which one was better and whether they were both clinically equivalent. And what we showed in our analysis, this is for chest X-ray interpretation, that 71% of these AI reports were matching or exceeding the human-generated reports in a blinded assessment. And if you look at the breakdown in terms of normal or abnormal, basically on normal scans were equivalent. It's the abnormal scans on which there's some subset of cases for which the humans are still doing pretty well. It'll be interesting to see experiments that we did was to say, if we start with these draft, what is the variability in performance between different people? And there we see a similar story, is that people benefit on average, but there's a large variability in terms of who benefits. We started a competition on this task of radiology report generation. to verify them, and ultimately submit the report. What would have taken a couple of minutes can now happen in less than a minute. And that's how the future is going to be, not just in radiology, but across. This is a multimodal AI workshop. And so one of the efforts on the multimodal AI front has been data sets that can really allow us to approach in our modeling different data sources. We have now released what is the most comprehensive emergency department data set called MC-Med. It is data that's been curated over a span of 118,000 ED visits, in which one of the unique things about this data set is that we have continuous monitoring and complete clinical context, both paired together in the emergency department setting. So true sandbox to allow us to test what happens with multimodal model if you want to understand a full clinical trajectory. I just wanted to put this slide in here as saying one of the main reasons that we're not seeing AI just used everywhere in the country in US is that it's still unclear who pays for AI. And if you look at the ways that we've thought about American healthcare and technology and service reimbursement, AI has yet to find a place in the reimbursement landscape, although there are pathways to what we call a generalist radiology AI or generalist medical AI reimbursement. And I just want to leave these keywords on there in case that's of interest to someone in the audience. I'll just end with a few snapshots of the latest research and then end there. One of the things I've been very excited about is the ability to just completely solve chest X-ray interpretation in the near future. And towards this, to add to what is a large public set of chest X-rays already that's been released by over 3-4 institutions. We actually released what is now the largest by number of patients chest X-rays in the world, with 109,000 unique patients that were data collected from 79 different medical sites. And this is completely open for non-commercial, non-profit use. But what it allows us to truly do, I think, in a very compelling way now, is to actually evaluate the performance of report generation systems across different health systems. We have 3 different health systems represented in this data. This is fully de-identified data where you have scans along with structured reports that are available. On top of this, we have recently, as of last week, created a new benchmark called REX-VQA, in which we are formulating visual question answering tasks that would represent one of the more challenging benchmarks for multimodal image interpretation today, where you have to understand the question, look at 1 or more images, and then answer the questions. And we've constructed 696,000 questions across these 160,000 chest X-ray studies. And just as we were about to make the paper public, saying there's nothing that outperforms the best resident, we added MedGemma on this leaderboard, and it actually is doing pretty well at VQA, though not at report generation. And so we scrambled to update the paper with that. One of the things I'm proud of in this data set is that we really focused a lot on the clinical authenticity of the questions, which has really been missing once you go 1 level deeper into existing clinical VQA data sets. And so that's a part that I think we've gotten right through improvements. One of my students was interested in understanding when radiology report generation models hallucinate. And so we developed a temperature-based sampling method to detect these hallucinations, which could be individual lines in reports that can be precisely flagged. And this is a little bit of the schematic that allows us to have a method which gets us from 4.2 to 1.9 hallucinations per report. As you can see, there are a lot of hallucinations to begin with. One of my students, who's actually an undergrad, did this fascinating work that was that is being presented at CVPR, the main conference this week. That's called Fact Checker, And the basic idea behind Fact Checker is to be able to mitigate hallucinations by looking at whether the model is trying to place ET tubes and to be able to correct that by leveraging a specialized model to essentially correct the measurement of the ET tube location and re-inject that back in the report, which is what we call a query code update paradigm here. There is going to be a lot of excitement on the 3D front, whether that's through 2D volumetric scans or through videos. And we have taught a little bit about how we can have this multi-phase synergistic analysis be possible finally with being able to model these 3D videos. And of course, the opportunity for real-time applications. One of the things that is still a dream of mine is in real time the ability to help with intraoperative procedures or with endoscopies in order to be able to discover and really help in real time. This is one of the work from Akshay's lab that looks at once we have preference data collected from people looking at these reports that have been outputted, how can then be used to update the model, and some innovation around how top performance on a metric can be achieved as a result of improving using these preferences. And then finally, one of the important areas which is emerging is the ability for us to define the boundaries of what one LLM should do with tools and what another one should do. And one of my colleagues imagined in this Nature Biomedical Engineering paper what that world is going to look like in the future, where we have all these different agents that are going to interact with each other and have access to their own knowledge base and tools. And this is a schematic of the wild world that we're going to live in not so distant future, in my opinion. People are already trying to implement this in practice. This is one of my colleague Michael Moore's papers called Agent Clinic, which is evaluating AI in this agentic way in a simulated clinical environment and showing, again, a drop in performance from a static setting to a truly dynamic setting. And that's something that I expect we'll have a lot of progress on. I'll end with my last two slides, which is one, if folks are interested in getting involved in the kind of research that we do, one of the unique things about our lab is we host this thing called the Medical AI Bootcamp. This is open traditionally to both people trained in AI and people who are trained as doctors. Doctors have been from anywhere in the world. Students have been typically from Stanford, Harvard, MIT, but we're expanding it to whoever's a student on the AI side at this point. So this might be something to take advantage of. And incredibly grateful for my lab members, colleagues, and thank you for having me.
We only have time for 2 quick questions, so yeah, humble request to keep them short, but yeah. Thank you, Pranav. That was an amazing talk. I really got some awesome ideas out of these. All right.
I'll ask you a question. So on one side, you talked about the lack of CPT codes for reimbursement. Do you think that it's the finances that's a problem or the lack of value that these models are showing in clinical practice that's the problem?
I think it's a combination of the two, but I do truly believe that these models are going to generate value. And when that happens, we're not going to have any CPT codes.
Thank you for the great talk. And in my short experience of like few years, one thing that I have seen associated with clinic is that clinicians are not comfortable adding that extra 10 seconds with these AI models are trying to bring. So from an AI engineer perspective, I see that there's a lot of value that these models bring. But
cost of the change management, even mentally at an individual level. Great. Thank you again.
We're going to take a short 15-minute break and then we'll resume. Thank you. That was an amazing talk.